Hi, good morning. Welcome to episode 4 of mentoring session on C++. I hope you have been following all the topics that we have studied till now, as we have already done our 3 episodes. So all the recordings are available. If you want a review, you can go through them on our YouTube channel. Today, we are going to have the discussion on the scope resolution as well as the templates. We try to cover this because we are still left with few topics from the previous episode. We were not able to cover it out. I was left with around 2-3 subtopics from the functions. So we'll be starting from that, and then we will be proceeding further. So anyways, can somebody confirm me my audio and video? Is it okay? Especially audio is very important. If it is okay, please confirm any one of you. And in the meantime, I'll just take you through the yesterday's content that we have covered. Okay, Rudra says good morning. Sir. Hi, good morning, Rudra. Kashish is saying yes, sir. Both are good. Great. Thank you very much for confirming that audio and video are going great. So yesterday we actually spoke about these particular topics. We detailed and discussed about we had a detailed discussion about the control structures, in which we spoke about the sequences, selections, especially if else and if else if. Then we spoke about the switches. We actually did a comparison between them, and we actually saw that how exactly they are being programmed, what are the different kind of benefits they have. Along with that, we also went through while loop, do while loop, and for loop, and we actually compared them that, okay, for is for the range specific things, and whereas while or do while is for basically some kind of iteration till some exit condition has been recognized. And again, while and do while, we discussed about that while is a entry check loop, whereas the do while is a exit check loop. Okay, so at least once the do while will going to execute, whereas while will only execute if the expression is which is under the consideration is true or not. We also looked at the flowchart modeling by using a Raptor tool, which is a very beautiful tool. I hope you people have downloaded it and practiced on it. If you are new to any programming language, specifically C, C++, you should be actually practicing in this particular tool first, so that you should be able to understand the logical part of your program or algorithm, right? Then we discussed about the functions. We actually looked at that how the block of code has been used to define or segregate the particular set of operations, very specific operations which are supposed to be used multiple times. And apart from that, we also actually went through that how we define the prototyping of the function, where you define the signature containing its type, return type, function name, and the argument list, right? So that is what is there. Apart from this, we actually looked at the inline functions. Now, this is where we stopped, and inline functions. Yesterday, I was not able to cover one very important thing corresponding to inline function, and that is this. Because we are doing a function call, we know that whenever a function is going to be called from a particular from any of the method, in that particular case, it is going to send a call to that particular function, and jump or branch instruction is going to get called in the underlying architecture, right? But how we track that, okay, from where the call has happened and how I'm going to return back to that particular call, right? So let's look at this particular function definition. This is a function foo, and this function foo is returning foo itself. Okay, so that means this function is actually calling itself, and again, it's one of the concept from the recursion. So I'm just taking an example here, and this foo is being called from, let's say, a main method. So if it has been called from the main method, so that means we are going to jump out of the main first. So stack is actually going to maintain all the function flow. So that means the main function, once it is going to jump to the foo, the main function is going to be put into the stack so that whenever the foo function call is over, it can return back to the main. Now, why stack is being used? Because stack has a property of first in last out, or last in first out. LIFO you can also say. So whichever the call happens at the latest time, that will be on the top, and whichever happened at the earliest time, that will be at the lower part of this particular stack. So let's say from the main method the foo is being called, that means the function call is going to get transferred to this particular place. So in this particular case, what is going to happen is, first the main is going to be get inserted into this particular stack, right? So from here, the main is going to be saved for returning purpose. Now then, because the foo is going to get a call, and this foo is going to get another call to this particular method, so that means this foo is going to be pushed toward the next stack, right? And once this foo call is going to come at this particular place, because again it is going to call a foo, so that means this call is going to also get into the particular stack part, and this will go on because this is a recursive function and there is no exit condition which has been put into this particular part. But anyways, you should always remember that whenever a function call is going to traverse between the different functions, then a stack will be maintained corresponding to have their flow of calling. Okay, so this is what is happening in the background within the memory system, even though you are sending a call to different methods. So this is the reason why inline functions were introduced. If we know that there is only one set of instruction which is to be executed, right, we can put that instruction within the code itself. Okay, so wherever this foo is going to get called, the expression is going to be replaced on that particular specific call. So overall, inline functions are used only to replace whatever the code is defined inside those inline functions, and then your compiler will work out corresponding to the compilation purpose. Okay, so that's the purpose of what we have the inline function. Now let's look at the agenda, what we have. So we are going to cover the functions and overloads, and the left out topics we'll just see in a couple of seconds. Then we are going to look at the scope resolution, which is very important topic. A lot of questions comes in the placement interviews or placement tests corresponding to this particular scope resolution part. And then we will be looking at the templates, and I will be strictly taking care of the time today. I will be strictly completing our webinar at 12 o'clock. So the flow will be again same. I will be discussing about these topics, and in the meantime, if you find any queries or doubts corresponding to a particular topic, please write in the comments, and in last 5 minutes of the webinar, we will be taking your queries. So let's start with the functions first. So there are a few concepts which we left yesterday. One is the call by value and call by reference. This is a concept where we are actually taking care of our variable copies which are to be sent to the functions. So let me write a program for you, a very small program. Again, I'm taking the example which I have done yesterday. So I'm writing a int add method or add function, and then I'm writing int a, int b. So there are two variables which I'm considering. It is going to have a return statement, which is a plus b is going to be sent back. Okay, so let's say I have a main method which has an int return type again, and that main method is going to have a certain variable again. So maybe int x, which is equals to 5, and int y. I'm explicitly defining them. And then what I'm going to do is I'm going to have int result equals to add 5 and 6, right? Okay, so instead of 5 and 6, I made a mistake here. It should be x and y, right? So right now, what exactly is happening is, or maybe we do a cout statement, and that cout says result will be result. Okay, so this is what is going to get printed on your screen. Now, when we talk about this particular part call by value, so what exactly is happening is within the main method, when we are setting the variables and we are calling a particular function and we are passing both the variables which were set here as an argument, first argument and second argument to this particular function, the underlying memory, what exactly will be happening is, let's say the x and y were stored as a memory 5 and 6 at some location 0 1 1 1 x, right? Sorry, x 0 and 0 x 1 1 1 1 is the memory where they have been stored. Now, if we look at the particular call by value part, so what is going to happen is whenever this particular instruction is going to get called, right, in that particular case, two more memory locations will be saved or reserved, and the value of x, because x is going to be passed on to a and y is going to be passed on to b, so a is going to reserve another memory location and b is going to reserve another memory location corresponding to these two values. Okay, so that is what is the concept of call by value. So that means maybe 0x11111 is certain location, or maybe 0 at this, and 11111 is the location where the values are being stored. So two different copies of the values are being maintained. So whatever the operation which has been done on these set of memories will only applicable to the storage area, and these values will not be touched. Okay, so there will be no change in these particular set of values. So if you are looking at that particular type of scenario, then call by value is the best way for your function calls. Okay, but the only drawback is that you are going to use a additional set of storages for whatever the number of variables you are passing as an argument to that particular function. Whenever it returns back the particular result, that result will be stored separately and a memory location, and that could be another set of memory location 10000 and so on. Okay, so that could be a memory address for that particular result variable. So we are using in total 5 different locations. So if I talk about this particular single set of programs, so overall the memory requirement will be, because we are considering that int is going to have a 4 bytes, so 4 bytes for this, 4 bytes for this, right, and 4 byte for both of these variables, and for result variable another 4 bytes. Okay, so we got somewhere around 20 bytes for this particular set of function in terms of the memory utilization. So this is a very important concept that sometime your interviewer may ask in your placement related thing. Now let's look at what exactly happens in the reference part. So what I'm going to do is I'm going to erase some sections of this particular presentation. So let me do it quickly. Okay, so here. Oh. So here, what we are going to do is, now there are small changes I'm doing here now. So what exactly is going to happen is the result. Okay, so when I'm defining a particular function in terms of call by reference, what we can do is we can do int. There are two ways to do it. Either I put an n% here, a, and then int n% b, right? So it's an n% sign. And then instead of now here, what I'm going to do is I'm going to pass x and y directly. Okay, so when I do x and y directly, so I may not require to have this result. I can show you that in another example as well. So what exactly is going to happen right now is in terms of the memory allocation part. So here in the memory allocation, the value what we are going to have is for x and y, that is again 5 and 6. Okay, and there is another set of variables which are being created, that is a and b at this particular part. Now mind it, here what exactly is going to work out is, here is the memory address, right? Here is the another memory address that we have. Okay, now instead of passing the values, we are actually going to pass on the references addresses to this particular location. So what we are going to have is 1110 and 01111. So this is what I'm going to get is a reference to the memory addresses of these variables directly. That is what exactly happens in a reference. Now what difference I did here is I only utilize the n% with the argument variable of a particular function, and then I passed on the particular set of variables as arguments from the main method itself. So when you talk about this particular concept, we are actually, instead of sending a values directly to these particular arguments, we are actually sending the reference, the address of these variables, memory address of these variables, to the arguments of these methods, and those arguments will be utilizing the references. And then when this expression is going to be solved, this a is going to resolve to this particular value, and this b is going to resolve to this particular value, and then the particular function is going to return certain value correspondingly. Okay, so this is a typical not I would not say typical, the simplest way how we do the return statements corresponding to my call by a reference concept. So we are actually, instead of copying the values, we are working on the actual values of that particular system. Okay, now what is the benefit here? Now we said 4 byte is used by this and 4 byte is used by this, so total is 8 bytes. Whereas if you look at this particular address, this is only using, if I make it to the, let's say the limit what we are having right now corresponding to the system is system addressing is 2 bytes. Okay, so let's say my addressing is represented by the 2 bytes. Generally it has been addressed by the 4 bytes if it is your 32-bit system, and 8 bytes if it is a particular 64-bit system. So if I'm considering of 2 bytes right now, in that particular case, the total memory requirement which will be there for this particular system is 4 plus 4 plus, because these two variables are only using the 2 bytes, so that means 4. So total requirement will be 4 bytes in comparison to the 2 bytes. Even if we take 4 bytes in that particular sense right now, and if I consider this result as well, so again this is going to hardly use the 16 bytes correspondingly. Okay, so that is what is the real benefit of utilizing the references directly. Most of the time references are being used when a direct change in these values are supposed to be done on the particular variable values. So let's say if I wanted to do the increment on the x itself, then I can do that particular prospect as well. So maybe I can do the whole thing from the scratch. So let's say I'm writing a particular function here. Maybe let's say instead of using the int, I'm going to use a void return type now. And let's say I write increment. INC stands for increment, and I'm putting up a reference of single variable, right? And then what I simply do is a plus plus, and that's it. So I'm using a unary operator, okay, increment operator here. So within this main method, what I'm going to do is, inside the main method, let's say I define a variable x equals to 5, and then what I'm going to do is I'm simply going to do a function call using a cout statement. And here what I'm going to do is next value will be, right? So I'm writing it in the next line. So inc, and the variable that I'm going to pass into this particular part is this. Okay, and then if because the return type is int, so I'm going to pass on to the pass on 0 back to the function call, main function call from the operating system. So what exactly is going to happen is, I have a memory here, right? And that memory has a variable x. That variable x memory stores the value 5. There is certain memory location. Okay, so whenever this function call is going to happen from here, this function call is going to send a particular address to this particular variable. So right here I have a, and that is going to store the reference. Now whenever this a++ is going to happen, it is going to refer to this particular part. And directly what is going to happen is, because we are doing the referencing, this value will be changed from 5 to value 6 automatically, and the printing will be displayed as next val equals to, or maybe colon is 6. So this is what is the output that is going to be displayed to the particular output console. Okay, so that is what we get in terms of our referencing. Now, if you have worked on C++, sorry, not C++, if you have worked on C language, you might have seen a different, corresponding syntax. So what could be the possible syntax you have seen is, you might have seen the syntax like that here, instead of sending, you might have seen like this, you are defining a pointer, and here instead of sending the variable directly, you are doing an n%, and then you are going to have a x value. So this is also does the same thing, but here the change which you have to do is, you have to add the streak with this particular variable. So that's a basic difference what you can have in terms of your variable uses. So references can be done in these two types. So it's very important to understand that C++ has certain added attributes, and the %, the previous one, the previous format that we used, is more suitable in terms of the nomenclatures of the C++. So this is what is the basic reference. So I have actually curated search for a video. This is one of the best references which you find. So pass by references, you actually send the reference to the same copy, whereas pass by value, you are going to make a copy of that particular value, and then you are going to send it to the function. So this is the basic difference what you may visualize in terms of the general day-to-day use cases. So call by reference, call by value is one of the most important concept. It is being very frequently asked in the interviews by the interviewers, and they will also ask you to write a small program or something relevant stuff correspondingly. So it's very, very important to have the good understanding of this particular concept. So Adhiraj Pratap Singh is asking that, sir, how to do same by the operator overloading. So Adhiraj, we are doing this particular operator overloading in our 7th lecture, right? So when we are going to discuss about the classes at that point, I will be covering this particular concept. So please do attend that particular seminar. Right now it's out of the scope because we are putting the stress on the very basic concepts. Now next thing is, because for operator overloading you have to go through the classes itself. So next thing, what are we going to do for the next part is, that is the default arguments. Now default arguments is another attribute which has been added by the C++. Default arguments allows you to give certain default values to particular set of variables, right? So if I show you the example correspondingly, so what exactly is going to work around for that? So let's say if I have a particular variable, int, particular function, and it has a particular variable, let's say a, and int b, okay, and then there is a particular block for this, that is, let's say, return. We are writing c equals to a plus b, and we are going to return the value c to the calling function. Similarly, in the main function, what we are going to do is, we are going to have a int x that is equals to 5 and int y equals to 6. And then what we can do is we can simply do a cout sum equals to, and we are going to call a method, and that is 5, not 5, x. Okay, now if I do this particular part only, we are supposed to have two parameters here, right? And I'm just only passing on one single parameter. Okay, so in this particular case, what we can have is, like, if you want that certain functionality to be taken care of, let's say if the user or programmer is not giving you the second value and you wanted to have that particular operation fulfilled, what you can do is you can actually simply pass or initialize the value to that particular second parameter directly from this particular uh, s- uh, argument list itself, right? So this is what you have in terms of defining the default arguments, right? So you have actually given a default value corresponding to it. Or maybe you can also have, the beauty of this is that you have a sum here, right? Another sum, and then you have another function call that is being done where the two variables are being passed. So here, for the first call, only 5 will be passed to this particular value. The output for this particular cout will be sum equals to, because we have x equals to 5 and b equals to 5, so that means the sum will be 10 right now. Whereas if you go for the second cout, what is going to happen here is that your argument b is also passed with a value which is 6. So in this particular case, the sum is going to be 11 because b is going to get a value 6 over here. Okay, so in that case, the default argument will ignore its default value. Okay, so this is what actually happens in terms of your default argument. And if we go and look into our code block, so here what we can do is, let me do a copy of some of the content. So I'm writing the same function again. So maybe new dot cpp. Okay, so let's say I'm writing int add or int a and int b. Default argument I'm passing 5, and within this, because I'm supposed to do a prototyping as well, which is a best practice. And here I'm going to define it as, let's say int c equals to a plus b, and that is supposed to be returned back to the system, and that is like this. Okay, and here what I'm going to have is, let's say I'm going to write int x equals to 5 and int y equals to 6. Okay, so here what I can do is, now if you remember, I'm directly, if you remember from the slide, what I did is I directly used the function call here, right? So you can do the function calling from anywhere. So adding the number, and that is the x. So right now I'm doing only the one single argument passing, and then in the next line I'm going to have a 2 argument passed to the particular system, right? So once I run this particular program, okay, so I am getting an error. Great. So I added another symbol over here. 2 parameters. Default argument int. Oh. In prototyping, I can do the simple part as well. Too few arguments to the function. So what I did is, because the scope was not defined, great. So I was able to run. So right now, what exactly I did is, I'm not sure why the prototyping did not work for this particular part. Anyways, So we have some as 10 at the first place and some as 11 at the seventh place. Now, why it happened? Because your function, your particular function call, the very first function is going to only pass the value of x, that is 5, and second function call is only going is going to have both the parameters here, that is x and y. So this is the reason why we can have the default arguments in the place. Now there is one particular uh, you know restriction in this particular system, that you have to start the function default arguments to be done from the right hand side, not from the left hand side. Now I have done this from the from the left hand side. So it says the default argument missing for the parameter 2 int add. Now the problem is why it is displaying me the error, that because we cannot do this kind of signature definition. So it is not allowed to do the default argument values from the left hand side. It is always allowed from the right hand side onward. So if I have more than one variable, more than two variables, let's say int c as well. So in that particular case, if I pass on a value here 10, so this is a valid definition for that particular declare in the C. Okay, so there is another param name conflict which happened. So I'm going to have it as a Z, right? Because C was declared inside this particular function. That is why it displayed me error. So here, if you look at this particular function, we can have more than two arguments with the more than one argument with the default value, total in 3 arguments, but the default arguments will only start from the right hand side. Okay, so that's the more important thing which you should keep in mind. This is the place where interviewer can ask you, okay, default arguments are there, but how can we define them? Any restriction is applicable on them or not? Okay, so here if I make a change in this particular expression, you will find the difference in your output corresponding to that particular function call. So you can see we have, for the first function, we have only passed the one single variable. The sum is equals to 5 plus 5 plus 10. Whereas for the second function call of add, we have passed two parameters. So 5 plus 6 plus 10. So that is why this is the difference what we are looking at. So this is how you can actually go and look at the default argument utilization. Now, what about the next, constant arguments? Now, constant arguments are again great thing, because we have studied about the references, right? So if I say that I am defining this particular variable as a particular reference, and that means here I only need to pass on the values correspondingly, and I wanted to have that particular variable to include the final result. Okay, so I'm going to type simply a equals to a plus b plus z. So that means I'm going to work on the variable address directly. So here I also wanted to see what exactly is the particular the changes which I make is I'm removing the type, right? And then I'm going to print the value of x itself, right? Here I'm going to call the method x at the add at this particular place itself, right, with the single parameter. Let's see, because this is the first time I'm going to run this. The sum is simple. Let's run this particular program. Okay, so I have not passed on the semicolon, so that says compilation error. So if you look at this particular part, what exactly is going to happen is that we have passed on the value of x, right? And that value of x is now being changed directly, right? So this is the example of your call by reference in this particular function. Okay, so let's say if I take the value from the user, c in x, right? First I'm typing c out for enter the value of value to be added. And here I'm going to remove this initialization handle, and that's it. In this particular case, what I'm trying to do is I'm going to ask the user to put the value x, and then we can see what is the value of x is going to be changed. Change the value of x variable after the add function call. Okay. So if I run this particular program, all right. Great. So it is asking me to enter the value. So I enter value 2 and changed value of variable x after the add function call is 17. So that means default arguments which were used here is 5 and 10. They both are being added to value a, which is actually a reference to the variable x from the main function call. And that is being printed over here itself. So 5 plus 10 plus 2, that has been directly added to the x variable reference, which has been passed to the variable a in this particular add function, and then that value has been printed over here. So this is what is the beauty of your references that that you work around. So this is what we have for the function part. So last one which has been left out is, okay, the constant argument I wanted to speak about. So let's say if I want some values not to be changed during the particular function call when the references are being passed. So what I can do is directly I can pass on the constant part. Okay, so I'm just simply replacing this thing with the constant. So if you try to do that particular thing, you can actually see that the reference which is being passed is it is displaying me an error. It says that assignment of the read-only reference is A. Okay, so that means if you are working around with certain methods, and you are trying to optimize your memory, but you do not want the actual references to get changed. In that particular case, you can simply add this constant keyword along with the variable argument variable definition for that particular function, and this can be taken care of by the compiler itself that the reference value should not be changed directly. This is another question which has been asked in the placement interview. So they can simply give you a scenario that, okay, I have two references and which are going to be passed on to the method call or function call, but they should not be changed. So this is what you can actually do in correspondingly, and this is quite a good trick which you can work around. Okay, so that is what we have corresponding to our constant argument. Now next thing which we have is the recursive function. Now recursive functions is another beautiful concept, and this concept actually tells you that, okay, you are going to call the function itself, and there is you know there is some exit value you have to take care of. So what could be a possible call for this, like we have actually seen in this particular picture, that foo function is calling itself. So it is a recursive but infinite recursive loop which is going to happen. Okay, so let me write a small method for you. So even though I've written it a program on factorial, so factorial, what it says, I'm going to take the same example. So if I wanted to calculate the 5 factorial function, so the point what you can do is the mathematical calculation says 5 into 4 into 3 into 2 into 1. This is what we have. But if we take it as a n factorial, the notation will be n into n minus 1 into n minus 2 into n minus 3 and so on. Okay, till the time the n is greater than 1. Okay, for this particular expression, can I write this as, let's say if I want to break this particular expression as n, which is n factorial equals to n minus 1. Okay, now I take this particular next expression n minus 1, and that will be n minus 1 and then minus 1. Actually it is going to notate you as n minus 2, right? So that means we are talking about this particular set. Okay, then if I take this particular thing on the right again, n minus 1 minus 1 equals to n minus 1 minus 1 and again minus 1. Okay, so this will bring me the notation again n minus 3. Okay, So this is what we have in terms of our factorial part, and I can plan it as a function itself. So let's say if I'm defining a particular function, I say int, I say fact, and I'm passing a value that is n. Okay, that's the first value we are going to pass. Then what I'm going to do is I'm going to do if I talk about this particular thing in a minute. So what I do is for next function call, because I need to take care of this as well, so I can do is as fact, right, and n minus 1. Okay, so if I look at this particular function, fact n, so that means the argument which we are passing is a value. So I'm starting with the fact 5. So that means this call is going to have fact 5 minus 1, that is the next function call will be fact 4. Okay, so here this call can go, and I am going to just simply have a return call here, right? So return will be sent back. Now it will go on because n minus 1, next time we go for next function call, so it will be going for fact 3, fact 1, right? Sorry, 2. Then it will go for fact 1. Then again it will go for further fact 0, fact minus 1. So I have to stop it somewhere, right? So where I have to stop? Before 0. I should know that, okay, 1 has been encountered, now it should be stopped. So for that I need to put a exit condition. If n is equals to 1, right, simply return 1. So that means if n equals to 1 is being found, you will directly return back from here, right? So this is where the function call starts going back, right? So it will this function will return 1, function will return 2, this multiplication, and this function will return this multiplication, and this function will return the total multiplication from this to this, and then finally we have this particular set. So this is how you actually define your recursive function. You have to plan it on the paper before you actually go and write the code for that particular recursive function. Okay, now let's go and look at the code that we have written previously for the factorial part. So we have this long factorial value which has been defined, and the long number which has been defined. So here, if we look very carefully, what we have is that we have actually looked at the value n. Okay, so maybe I can change it to n instead of a, so that you should be able to do the correct notification. n. Okay, so here what exactly is going to happen is, whenever a function call is going to happen for this particular factorial, the value is going to be passed from the main method, and this is the initial value from where you start. You pass on the value, and then once the value is passed on, you will be looking at that, is this particular value is greater than 1, then I should be returning this, else I should be returning this particular part. Okay, so if you wanted to change this, you can change this to the this particular logic as well. Okay, so what you do is, you are going to return the value of n into factorial n minus 1. So that means next notation you are going to pass on here. So n into n minus 1, and then next function call will be going to send you n into n minus 1. So there, this will go until the value has a 1, value has equals to n equals to 1, right? Or n less than 1. So here what I'm going to do is, I'm going to ask the user cout, enter the value for which the factorial is to be calculated. So this is the best you should do always. You should ask the user to enter the values, and cin, where I wanted to do it inside the number, and that's it. So I'm going to run this program for you again. So here what I get is, enter the value. So I'm going to have a 5. It's a factorial 5. And then again, if I run it, right, and then if I say enter the value for, let's say, 8, that is what I get. Okay. Now sometimes you have to do it recursively, right? You want to do the notation number of times. So what you can do is you can ask a particular user to do this stuff for you. So let's say while I'm writing a function while the construct while, and then I'm going to have a flag, let's say boolean or maybe some value. Maybe I have to put a flag here. Flag equals to true, and that flag is of boolean type. Okay. Now, while the flag is true, this thing should work every time. Now, this is a trick to make it more interactive to the user, right? Here I can again type out C out. Do you want for the next number 0 for yes, 1 for no. Okay, so this is what I am going to do in terms of making it more interactive. Okay, and then we can have it in cin, maybe some val, and val equals to, I'm making it yes itself. If val is equals to 1, what I can do is I can put a flag equals to false, right? So this is what I have corresponding to the flag part, and this is it. So this logic is for asking the user for multiple times, and this logic is for doing the actual calculation. So let me see if it works in a way I wanted to have. Okay, declaration, it says count. Okay, I misspelled it. Great. So here, let's see what exactly it is going to display me. I say, okay, 5. Do you want for the next number? Yes, I want for the next number. Enter the value for to be calculated, 6. Okay, 720 has been printed. Do you want it for the next number? Yes, I want it for the next number. I want it for 9. That is being printed. Do you want it for the next number? No, I do not want. Okay, so process is over. So this is how you can actually do your particular program as an interactive program in terms of even in C++ as well. If you are not very good in Java or Python and something else, you can actually go into this and do the similar kind of stuff. So I only written the extra 5 piece of instructions, and that actually allows me to do a kind of relevant stuff. So this is where we are going to stop for the function. So we talked about the call by values, call by references. We talked about the default arguments, constant arguments, as well as the recursive function. So you can do these stuffs together. So this is the typical example we actually looked at for the pass by reference and pass by value. Then comes as the scope resolutions. Now these are the most interesting concepts. So scope resolution are actually going to define that, okay, if I'm defining a particular identifier within a system, how much it is going to have a range of accessibility. Okay, so here if we look at this particular program itself, right, this long number can be accessed throughout these curly braces. So scope is actually defined by these curly braces. We call them code blocks basically. Generally, it has been named as curly brace block, but they are basically code blocks that you are writing. So how many code blocks this particular main function itself has? The first code block is the main code block for the main function. Second code block is for the while construct, and third code block is for the if construct. Okay, so this particular part, if we see, number and flag can be accessible anywhere inside of this particular code block, right? So starting from here, the complete main function we are saying. whereas the int val is only accessible within the while, right? So if you see, we have defined the int val here. Okay, so we have defined the int val. So int val is only has a scope within this particular set of code block of the while. So if I try to utilize this val after this, let's say C out, I'm trying to print value of variable val, right? And if I try to do a val, first of all, the IntelliSense is not displaying it. But once we go and try to compile it, you can simply see at the end the error has been displayed that val was not declared in this particular scope. So it's clearly an indication that the scope is basically on the basis of what code blocks you are defining. So in this particular part, the main function is having a scope of these variables, and these variables cannot be used the outside of this particular main part. So if I try to utilize this inside the factorial function, so let's say C out value of number variable, right? So that is what we are trying to print, and number, we will be trying to print it here itself. Again, if you see, it is displaying me an error that number was not declared in this particular scope. Now what I'm going to do is I'm going to take this number and out of the main function and define it at the top. Now what I'm trying to do is I'm trying to do a scope for the number variable uh, for a global program, right? So for the complete program. So if you look at this particular part, the this error is being gone, right? So what I'm going to do is I'm going to remove this instruction from here, and then I'm going to print it here, because if construct, I have to, if I'm using multiple lines, then I have to use a curly braces block corresponding to them. So let's say if I'm trying to print a particular number value within that particular factorial function. Before that, I also remove this so that my another error should not be displayed. So F9, now you can see the number can be printed directly. Okay, so factorial value I wanted to print for 3, and 3 factorial will be equal to the number of values 3. Oh, so here if you see, I need to enter some value first. Let me close it. I need to put some end lines so that the value should not be confused. End line here, and maybe another end. I add more end lines to this, and here as well. Okay, or maybe I put this too. Great. So now let's see what exactly is the output. This will be more, elaborative. So I'm going to enter 5. So the value is value of the factorial is 120, right? So what exactly happened is, because the function call is being done multiple times, the value of number 5, the value of number 5, the value of number 5, and the value of number 5 is printed. So 5 times it has been printed. So you can see how many times the factorial function has been sent a call, right? So this is what you can imagine in terms of that, how the factorial functions and what are the corresponding scopes for the variable. So this number variable is in a global scope, whereas if you talk about the variables which are defined as an argument to the function, they are in a local scope. Other functions, like in main function, the flag is actually flag variable is in a scope of these these curly braces blocks of the main function, whereas the val which has been defined, the val variable which has been defined, they are in another inside block which is for the while block, a while construct, right? So this is how you can actually define your scopes correspondingly in terms of global and local variables. So that is what you have for your global and local variable scopes. Now if you want to play with the nature of the scope of your namespace variables, uh, uh, with the variable global or local scopes, then you have to go for the namespaces. Now namespaces are really a great add-on to the C++ program. What it allows you to have is it actually allows you to organize the elements of the program into different logical scopes which are referred by their name. So if you look at the basic syntax, what we have in terms of the syntax here is the syntax is defined as a simple namespace keyword, right? So the namespace keyword is being done and the identifier is being provided, and any of the entity which you wanted to have it that as a part of the particular scope. So let's say the namespace, if we are actually defining it, the namespace will be used as a keyword and whatever the namespace you wanted to give as a name, and then you define the variable inside it. So how you are actually going to utilize these variables now? So what you are going to do is my name space and then scope resolution operator. Now you remember what we did in our operators, the scope resolution operator and then the variable name. Okay, so this is what you are actually going to utilize, and this is something which is the concept of abstraction in terms of your C++ program. So you are actually defining that, okay, what is the underlying entity that has been defined by the namespace, and it's like we are not doing any kind of overriding of any of the variables. So if I show you how you can do the overriding, one thing which I missed here while defining. So let's say if I'm doing a val here, let's say if I'm defining a val variable outside as well, so you will be able to appreciate that the variable val has been declared here as well as and in the while block too, right? And there is no error which has been displayed. So this clearly indicates that this val and this val are going to be different in the memory, right? So if I wanted to have this particular variable in this scope, it's not possible for me to do it. Okay, so for this, the namespaces can be defined. So let's say the namespace which I wanted to define could be like this. So namespace my var, that is the name which I'm going to give, and then I'm going to put a value 1001 so that we can have a clear indication that which scope I'm trying to utilize. Okay, whereas the another, let's say here if I'm trying to use it, so I'm going to use simply cout and val variable from the different scope is, now I'm going to utilize it as my var and scope resolution operator, and then I'm going to use val. Okay, so this is going to print me the value for the uh, namespace variable, whereas this is going to print me the val variable from the same scope, and I'm simply type the val itself. Okay, so this is what is the utilization. So let me run it again for you. So once I run this particular program, you can clearly see if I go for the 2, the value or the number variable is 2. This was done from the factorial function. The val variable, if you see here, the val variable from the different scope is this, whereas the val variable from the same scope is 0. So this is how you can actually see that how your namespaces allows you to use the same variable name, uh, same variable name, first thing without any error, second thing with the different scope levels, right? So the scope and the namespaces are really correlated. So global scope, local scope, and the namespace based scope. So that is how you define. So even if you remember from our previous program, or even in this program as well, we in the very first lecture or second lecture, we have actually spoke about these namespaces, right? So this is what you are trying to utilize correspondingly. So maybe if you wanted to have the variables from the different namespaces, that can also be utilized. So maybe if I remove this and put this particular thing as a namespace again, instead of defining this in a number as a global scope, I'm defining it in a namespace with this name as global variables. Okay, and then I'm doing it and giving it inside the particular curly braces block. Great. Now, if I'm going to use this particular variable, I can simply use this by writing using global scope. Which variable? Number variable. Okay. So this is another way how you can utilize this particular variable, which has been provided in the particular namespace. Now, it's not only that you are going to define the variables in namespace. You can also do the function definitions inside the scopes. So I'm writing it as let's say I'm going to run a particular function which is going to return me or print me the value of the numbers. So print number, right? And then I'm going to do a cout value of number for which the factorial will be done is, and that is number itself. Okay, so I have clearly defined the function here for the namespace, and then what you can do is you can call this particular function anywhere you want. So maybe I wanted to have it here. So cout, let's print the value for the value of the number which is going to get its factorial, right? So here what I have, and then namespace was global namespace, and then the variable will be printed through print number, which has a void type. And now if we try to do, okay, the operator, this, oh, great. So the problem is I've actually written, because quickly I wanted to finish this. So I have actually, I was doing this print here itself. So I'm not supposed to use cout with this particular thing. So that is why the error is being, displayed. So this is what happens actually in live webinars when you try to plan something and quick, when you get some plan immediate on the webinar, you're not in the right path in that case. So anyways, so value of number for which the factorial will be done is 5. That has been printed using that particular variable, that namespace scope part. Okay. So this is how you can actually do corresponding to your namespaces, and you can define your variables and functions inside the namespaces, and you can actually control that what should be the scope for them and how they can be utilized. Okay. Now there are certain rules which are there corresponding to your namespace usage or global scopes or local scopes. So the rules are that and their corresponding storages. So this is something which can be asked in your placements as well. So variables with the particular global or namespace scope is allocated for the entire duration of the program with the static storage. So that means they will be, once allocated with the memory, they will not their memory location will not be used for any other variable. So let's say the number variable, if it has been defined in the memory location, it will be there itself throughout the program till the time it has been stopped executing. And by default, the value will be set to 0 if it is not initialized. Whereas in terms of local variables, which are only available in their blocks, the particular storage location. So let's say if the val variable, which was defined inside the while block, if this particular variable is utilizing a memory, right, and once the while block is over, this memory will be uh, can be used by some other set of variable which comes after that particular variable declaration, right? So if the while block is over and if the value is val variable is not required now, so that particular memory location will be used by some other variables, and that means uh, the memory management will be done automatic. So this is the reason why we say the global or namespace scope variable as a static storage and other block variables or local variables as a automatic storage. And another part is these automatic storage variables are not, if they are not explicitly initialized, then their value is undetermined. You will get a garbage value corresponding to them. So it's very important to take care of these variables which are being defined either explicitly auto variables or by default as a local scope variables. So you should be very careful about defining their particular values. So initializing the value is very important for the local variable or automatic storage, whereas for static storage it is done. And in fact, you can use a static keyword as well. In some programming language, you can use static keywords as well for defining the static storage for your particular system. There is an extern keyword which has been used with the variables in the C++, that allows you to have a similar sort of functionality, right? So I think the time is again 10 past 12. So again, we got late by 10, got overdue by 10 minutes. So I'm very sorry for that. But anyways, I'll be stopping here. Templates I will be covering in the next particular webinar, which is tomorrow at 11 a.m. again. So we can discuss in that. So the floor is open for queries. If you have any queries, you can put in the comments and I can take those queries for you. In the meantime, I'll be displaying you my email address correspondingly. If you wanted to have a direct communication with me, you can have that with us on this particular email address, that is hello@superwits.com. And generally I reply within one working day. So you can be very specific with your query if you are not comfortable to put your queries here in the comments, or in case if you are looking for any kind of specific training with respect to Java, Python, and relevant stuff. So this is where you can put hello@superwits.com. Apart from this, I have a Telegram channel active on this particular link, that is t.me/Superwits Academy, right? So you can subscribe to the Telegram channel, and you can get the information, latest information on various webinars or other updates from Superwits Academy or from my side, whatever is happening currently, right? So that is what I have. Let me see if you have shared any queries with us. Okay, so looks like there is no query with you. So thank you very much for joining in for this particular webinar. This is Anupinder signing off from Superwits Academy. Bye-bye.